Hello, everyone. We're going to start Unit 1 by looking at some basic concepts associated with the time value of money, or TVM. So just so you know, there are some video links in Blackboard that are going to be extremely helpful to you. In fact, I'll go ahead and pull those up real quick right now, just so that you can see exactly what I'm talking about. So if I go to the home page, and I'll go ahead and put this in student view for you. And if you go into course content, Unit 1, what to watch, all the videos that we just saw listed on the PowerPoint slide can be found in this what to watch section. For what it's worth, the video that I'm recording right now can be found in the lecture videos folder as well. So these are great resources. If you're having trouble answering a certain type of problem, these videos actually go through how to calculate the different functions using both the calculator and Excel. And so if you ever get stuck, don't forget that these are available to you. These are a great resource to help you as you really get comfortable using both Excel and the calculator to perform these calculations. Okay, so now that we kind of got that out of the way, let's take a look at what time value of money actually is. So let's just pose this question. All else equal, if I offered you $100 today or $100 one year from now, which one would you take? Well, from a TVM perspective, you should take the $100 today from at least two perspectives. First of all, $100 today is worth more than $100 a year from now, right? If we consider the inflationary effects of money over time, then we know that we have more purchasing power with $100 today. The other reason that you should take $100 today as opposed to $100 a year from now is because you can put that money to use sooner. So let's, for instance, say that you wanted to save or invest this $100. Well, in the savings or investment account that money is held in, it can be generating interest or other types of growth over the course of the 1 year period, making it more valuable at the end of the 1 year. And so we wouldn't want to defer this from a TVM perspective. We would want to take that $100 today. Okay, so we kind of talked about those answers. Now, all else equal, if I offered you $100 now or $120 a year from now, which one would you take? This is a little bit more complicated, but I like to include this in this conversation because we can actually answer this question, right? A lot of times when we first start thinking about this at first glance, it becomes a preference decision, okay? And all of us have different preferences. And so some would say, I prefer to have the $100 now, and here's why. Others would say, I'd prefer to have the $120 from now, and here's why. But both would be preference based. Using our time value of money calculations, we can say, all right, what would we expect $100 to be worth 1 year from now, given a certain rate of return? Okay, and based on that rate of return, we can determine if $120 a year from now is a good deal or a bad deal. Now, if you're thinking about this as a relatively math-minded person, we know that $20 on $100 over a 1 year term is a 20% rate of return. And so if we're just objectively looking at it and saying, is 20% a good rate of return? We would say, heck yeah. 99 times out of 100, we're going to have a hard time beating a 20% rate of return over the course of a 1 year period. This is a great deal. I'm going to defer the collection to get the $120 a little bit later. All right, so time value of money is really going to help us quantify these questions objectively and determine what best courses of action might be. Okay. All right, so as financial planners, it's really important that you understand TVM concepts. Okay, and we're going to be looking at things like, which is better, more later or less now? How much will my investment grow? How much do I need today to fund a particular goal? How long will it take me to accomplish a certain objective? And so on and so forth. Okay, and we're going to apply those types of thought processes to questions like, how do we get out of debt? How much are student loans going to cost? How much do we need to save? what's the cost of major asset purchases? How do I manage credit cards effectively? What do I need to do to prepare for retirement? How do I need to manage my investments? And the examples go on and on. Okay. Now, some common terms that we're going to run into when we're talking about time value of money, rate of return. That's something that we'll use a lot. We'll use compounding. Oftentimes, when we look at compounding, we're looking at something we're looking at a value that's going to exist in the future. All right. When we look at discounting, it's the opposite of compounding, right? We're looking at a future value and saying, what is the present value equivalent of that future value? All right. So compounding, we're oftentimes looking into the future. Discounting, we're bringing things from a future time period back to a present time period. We'll also account for inflationary effects. Another word that you might see associated with inflation is called escalation. We oftentimes use escalation when talking about inflation around education. And then we'll have different terms that determine the timing of payments. All right, so this is an ordinary annuity, which means that payment timing takes place at the end of a period, and then annuity due, which means that payments are taking place at the beginning of the period. Now, while we're on the topic of payments, I'm going to give you a very simple definition of a payment. A payment is something that happens on a recurring basis for a set period of time. Okay, so a good example of a payment is a car payment, right? If someone were to go and purchase a car and they used a loan to purchase that car, that loan is going to produce a payment, let's say of $600 a month. And depending on the financing term, let's say 5 years, then the person buying that car would make $600 payments every month for the next 5 years. So something that's happening on a recurring basis for a set period of time. The reason I go into this a little bit is because oftentimes when people start looking at this, they'll see one-time events that feel like payments, right? And so a good example of this is Bob received an inheritance. He invested it into the stock market. All right. And so it feels like that investment into the stock market from the inheritance is a payment. Well, it doesn't meet the definition, right? It's not something that happens on a recurring basis for a set period of time. It's just a one-time event. And so we have to be really cognizant of what constitutes a payment and what doesn't. But to the terms that we're looking at here, we also need to know when payments are present, do those payments take place at the beginning of a period or at the end of a period? Now, when we're looking at our calculator and dealing with the time value of money, or if we're looking at Excel, there's 5 functions that we deal with. We deal with present values, interest rates, terms, payments, and future values. Okay, and so over here you have some basic definition of what these different functions represent. Okay. And when you're looking at these different things, just so you know, when you're working these problems, you're either going to know or make assumptions about 4 of the 5 factors, and then you'll solve for the missing factor. Okay, so if you're trying to solve for a present value, then you will either have inputs that you know or make assumptions about for the interest rate, the term, the payment, and the future value. Okay, so we'll have 4 factors that get input. The missing factor is what we solve for. All right, so it's just some basic calculator tips. And I'm going to go ahead and pull my calculator up after I go over these really quickly. We always want to set our calculator to 4 decimal places. This just helps for clean and consistent rounding. I'm going to give you the advice, even though it's not required, I think it simplifies to set our payments per year and our compounding periods per year to 1 and leave it that way. Make sure that we're clearing out our calculator before we work any new calculations. And then we're working on learn some special features and really developing our overall skills around TVM concepts. But let's go ahead and take a look at that calculator real quick. And let's talk about some of these functions. So you notice on your syllabus that the BA2 plus Texas Instruments calculator is what is required for the course. It's also what's going to be required for future courses in the program. And so it's going to be great to learn this on the front side. Okay, so here's your factors, right? Your term, your interest rate, your present value, your payment, and your future value. We have all 5 functions on the 3rd row of this calculator. Okay, so to set our calculators to 4 decimal places, which this one already is, you hit the second key. Anytime you hit the second key, it's going to perform the function in yellow above the button that you push, right? And so I'm going to hit the second key and then the format key. So its format is the decimal key at the bottom. And this says DEC equals, right? Decimal places equal 4, okay? If yours is something other than 4, then all you need to do is hit the number 4 and then enter. Okay, once you do that, you can hit clear twice, and you'll notice that there are 4 decimal places on the calculator. All right. Now, one thing to point out really quickly, and we'll talk a lot more about this in future lectures, is that there is an enter button and there's an equals button. Both of these buttons do very different things. And so if I say enter, I literally mean enter. If I say equals, I literally mean equals. Okay? All right, so the next thing we need to do is we need to set our payments per year and our compounding periods per year to 1. All right, so let's hit the second button again, and then let's hit IY. You'll notice above IY it says P-Y, that's payments per year. Okay, and it tells me my P-Y equals 1. So when I do a calculation, the calculator is assuming that when a payment is present, that payment only happens 1 time per year. Now, the reality is, like in our car payment example, we know that payments oftentimes take place more frequently than once a year. We'll talk a little bit later about how we're going to adjust for that. Okay, once we see, if it's not set to 1 on your calculator, all you need to do is hit the 1 and then enter. And then you can hit the down arrow and it says C-Y equals. That's compounding periods per year equals 1. So same logic from the calculator's perspective as what we just talked about with payments per year. If it's set to 1, and the calculator assumes that there's only 1 compounding period per year for the interest rate. We'll talk about how to adjust that later as well. Okay, so again, if you're not set to 1 right now, hit the number 1, then press enter, and then again, you can clear twice. Okay, we'll talk about some other functions in a lot more detail, but this at least gets you set up to where we are working on our calculator problems using the same formatting. All right, so we just took a look at the calculator. And so we got a good overview of that. Now, some things that might be helpful to you as you start learning how to work these problems are understanding your timeline, right? Some calculations are pretty straightforward, and you'll be able to easily identify your term factors just by reading the question. Others are a little bit more sophisticated, and establishing a timeline for the calculation can be really helpful in setting it up properly. The other thing that's going to be really important is properly assigning inflows and outflows. So oftentimes when we're looking at time value of money, the calculator is going to make assumptions about the inputs that are inflows and the inputs that are outflows. And so if we're thinking about this from a client perspective, right, let's just say that a client wants to know how much they need to save every month to reach their retirement goals. Okay. But when we're setting up the monthly contribution to savings in that calculation, then it needs to be shown as an outflow. And so when we're thinking, okay, well, how do I determine inflows and outflows? We always think relative to the client's pocket. All right. So is money flowing to the client's pocket, or is money flowing away from the client's pocket? Okay. So in this case, if we're making regular savings contributions to a retirement plan, then money is flowing out of the client's pocket to the retirement plan. And so those payments will be outflows. And then ultimately, when we figure out, okay, well, if we save $500 a month for the next 30 years, then the client's going to have $2 million. All right, well, that $2 million that we calculate is going to be a positive number. And the calculator is basically saying is at the end of the 30-year savings period, you have $2 million that's available to put back into your pocket. We'll talk about this a lot more, but I at least wanted to introduce it today. Again, we already kind of talked about beginning and end convention. Again, just the terminology for payments that take place at the beginning of a period is an annuity due and annuity due. That's a mouthful. And payments that take place at the end of the period are ordinary annuities. Okay, so we'll look at that in a lot more detail. The last point that this makes, and I don't think this actually says what I want it to say, but I'll clarify. Calculators use whole numbers when entering percentages. When we use Excel, we enter the actual percentage. Okay, so if we have a 7% interest rate that we're inputting into the calculator, we're going to input the number 7 for the interest rate. If we're using Excel, we're going to put in 0.07, right? The actual percentage. And so we'll look at that as we work examples. I just wanted to give you a heads up on the front end. All right, so here's an example of a timeline that you can use. And here's an example of a problem where a timeline might be helpful, right? Billy would like to plan for his son's college education. He would like for his son, who was born today, to attend private university for 4 years beginning at age 18. Tuition paid at the beginning of each year is currently $20,000 a year and has increased at an annual rate of 7%, while inflation has only increased at 4% per year. Billy can earn after-tax rates of return of 12%. How much must Billy save at the end of each year if he would like to make his last payment at the beginning of his son's first year of college? This is straight out of the CFP exam practice problems. And so they're trying to get you confused, right? They're using a lot of beginnings, a lot of endings. And so we really have to dive into this problem, but really sorting through what the timeline of this is can be confusing on the front side. And so setting up a nice graphic timeline, drawing it out, can be really helpful to solving this successfully. Okay, well, here's an introduction into some of the concepts that we're going to be talking about. Now you're at least aware of the direction that we're going to be moving in Unit 1. In your next video, I'm going to work some practice problems for you to really get you started off on the right foot. As always, let us know if you have any questions, and we'll be back soon with some additional content.